Hey guys, so in this video we're going to talk about 4.2 day 1, and so that's degrees and radians. So things that you're going to learn from this video today is going to be to convert angle measures from degree decimal form to degree minute second form and vice versa, and you're going to be able to convert degree measures of angles between radians and degrees. And you're going to find coterminal angles. And I know these are probably all new words, but you've probably seen some of it before. And if not, it's okay. Don't worry about it because we're going to go over all of that right now. All right. So what makes up an angle? In order to get an angle, you need to have two sides, right? And so here are some definitions for you. Your initial side is always going to be the side that goes along the positive x-axis, right? So that's this side right here. That's your initial side. And your terminal side is where the angle is going to end. So the angle starts with your initial side, and then it goes until a certain degree, and we end at what is called the terminal side. So terminal side is where the angle is going to end. So these two sides are what make up an angle measure, right? And if you remember from geometry, your vertex is another word for that angle that is created by these two sides. So an angle in standard position, like I said, is always going to start with the initial side on the positive x-axis. So this is the positive x-axis right here. All right. So let's talk about the concept of positive angles and negative angles. And so a positive angle is an angle that starts from the positive x-axis and then travels along with the quadrants, right? So it travels along quadrant 1 in order, quadrant 2, then quadrant 3, quadrant 4. Naturally, your coordinate plane works in a counterclockwise manner. And that is the positive direction for any angle. So this would be a positive, maybe measure of about like 200 degrees, let's say, because we know that a line, we're going to talk about this in a second, but a line is 180. So this is maybe 200 degrees. Now, a negative angle is when you're going in the opposite direction. So you start from quadrant 4, and then you work in a counterclockwise position, and you go in the opposite direction, and you make this. This is what we call a negative angle. So this is probably about negative 180 plus like 50. It's probably like a negative 230 degree angle, okay? And it's negative because we are starting from the positive x-axis and going down, going in the clockwise position, and that makes it a negative angle. Just some quick review for you here. If you look at the circle, a full rotation of a circle has 360 degrees, right? A straight line, so halfway through the circle, is 180 degrees. This is very important for you to know. I'm sure that you guys already know this, but if you don't, it's very important that you have it memorized like now. Obviously half of 180 is going to give you your 90 degree angle, right? And then if you add another 90, you're going to get 270. And then that's how you get a full 360 around the whole circle. All right, so let's talk about how our angles represented. We talked a little bit about what they look like. What does it look like when it's in its positive form? What does it look like when it's in its negative form? And now how are they represented? So degrees can be represented, obviously, or angles can be represented in degrees or radians. But before we get into radians, there's two ways that they can be measured in degrees, and these are the two ways. So an angle can be measured in your normal degree form, right? So this is called your degree decimal form, where it is in the units of degrees. You have the degree symbol here. And you could be very specific about what that angle is by having a decimal. Or you can resemble the angle measure in something called degree, minute, second form, DMS. And this is what it looks like. Instead of having a decimal, that decimal is then converted into minutes, which is denoted by this symbol. So write this down. This symbol is minutes. And it's also converted into seconds. And this symbol, write this down, is seconds. That's what you're going to, one of the concepts that you're going to learn today and go ahead and do. And you're going to have the responsibility of knowing how to do it for your homework. So make sure that you write this down and write down the conversion. And the conversion is right here. And that is that 60 minutes is equal to 1 degree. And 60 seconds is equal to 1 minute. You need this conversion in order to solve the problems that we're going to see. All right, so let's convert between each form to the other form. So this one is in degree decimal form. So I have 56 degrees and change. So my whole number is going to stay as degrees. So 56 degrees is going to stay 56 degrees. Now this decimal, this change, is what I'm going to convert. Okay. So I have 735 degrees, and I need to get rid of degrees, and I need to include now the next term here, which is your minutes. Okay, so I need to include minutes in here somewhere. So in order to get rid of degrees, I'm going to use my conversion, which I know the conversion is 60 minutes is equal to 1 degree. So I'm going to use this conversion to multiply by this decimal, and I'm going to figure what that is. And so I need to get rid of decimals. So I need to get rid of degrees. So I'm going to put my degree on the bottom. And in that way, I'm able to cancel out this unit here of degree. And I know that 1 degree is equivalent to 60 minutes. And I'm going to put the minutes there. Now I'm going to multiply these numbers, and I'm going to get what the minute. So my multiplication here, I get that this becomes 44.1. So I have 56 degrees and 44.1 minutes. Now again, I'm going to do the same process here with this decimal right here. And I'm going to work on that decimal to make this into the next term, which is seconds. So I'm going to convert this into seconds. And so basically you're taking the decimal and you're converting it to the term that's lower, and then you're going to the term that's lower until you're done. So this is going to be 56 degrees. 44 is our whole number for our minutes. So I'm going to leave it as 44 minutes. And you don't want any decimals in your minutes, and that's why we're going to turn this into seconds. So we're going to take this 0.1, it's a minute right now, and we got to turn it into seconds. So we got to multiply by a fraction that is going to compare our minutes and our seconds. And that is going to be that 1 minute is equal to 60 seconds. And so in order to get rid of this minute symbol here, I need to put a minute symbol on the bottom of the denominator in order to cancel them out. So now I know how to fill this in. So I want seconds as my answer. So in front of minute, here we have is 1. And in front of seconds, here we have a 60. So I'm going to put that in. And this part right here is going to end up giving me 6 seconds. So my final answer, I'm going to piece these 3 guys together, and my final answer is going to say 56 degrees, 44 minutes, and 6 seconds. And so I turned a degree decimal form to a degree minute second form. All right, so now in this problem, we got to do the very opposite. We got to turn it from the degree minute second to just degree decimal form. So we just got to turn it into degrees. So let's do these two separate times, okay, separately. So I'm going to do 5 minutes, and I want to turn it into degrees. And so I'm going to use this conversion because this connects minutes and degrees, and that's what I want. Now I want to get rid of the minute symbol, so I'm going to put minute on the bottom. I want degree to be in my answer, so I'm going to put minute on top. Now I'm going to fill this in. What do we have in front of degree here? We have the number 1. What do we have in front of minute here? We have the number 60. And when I multiply this, I get 5 degrees over 60, or I get 0.83 degrees. Great, so now that is in degrees. I'm good. Now I need to do the 28 seconds and turn that into degrees. So I need to get rid of seconds, so I'm putting seconds on the bottom. I want degrees on top, and now I'm using, actually, I can't even do that because there is no straight up conversion from seconds to degrees. I have from seconds to minutes, so I got to do that one first, actually. So I'm going to get minutes. So in front of seconds was 60, in front of minutes is 1. So 28 over 60 minutes is what this converts to. And then I got to multiply by this conversion, which is going to get rid of the minutes and give me degrees. And in front of degree is 1, and in front of seconds, in front of minutes is 60. And when I do this math, 28 over 360, I get 0.008 in my calculator. And again, this is in the degree units. So let's put this all together to get our answer. And the first part of our answer is 32 degrees. So 32 degrees, right? And then we have some decimals here. So we have 0.83 and 0.008. What I'm going to do is I'm going to add these two together so that I just have one decimal. So it's going to be 0. Oh, sorry, this was 0.83. Just looking at my calculator, it was 0.83. So adding these together, it's going to give you 0.913. And so that's your decimal part of the degree, and it's 32.0913 degrees. That's your answer for this. All right, so in this slide over here, I want you guys to pause the video and try it on your own and then get the answer. Hopefully you guys paused the video and you got the answer of 213 degrees, 52 minutes, 30 seconds for that one. And for this one, you got 89.9528 degrees. If you have questions with that, let me know. All right, so now we're going to convert between units and degrees. And remember, I told you that there's two ways to represent angle measures in a circle. You can measure them using degrees, which a circle goes from, any angle goes from 0 to 360. Or you can use what is called radians. And it's very important to memorize this piece right here, which is that a full rotation in degrees will give you 360 degrees, and a full rotation in radians will give you 2 pi. And so from this, we're able to say that 360 degrees is equal to 2 pi, right? Because a circle is equal to a circle. So 360 degrees is equal to 2 pi, correct? They are equal to each other. From that, I can also say that if I divide by 2 on both sides, which is a mathematically sound thing to do, I have the conversion right here that 180 degrees is equal to pi radians. And I'm going to need that conversion when I'm doing the following problems.